Welcome everyone to the BMCS and IMarEST Technical Seminar 2020 on Green and Sustainable Shipping, Making It Happen. I am delighted to introduce you to our speaker, Mr. Andrew Ong, Dr. Colin D. Anderson, and Mr. Abu Hassan Roni. We all know international shipping plays an important role to the world economy by transporting about 90% of the world trade. Being a key driver for the global economic development, it is also responsible for 3% of global emission. And if it is not controlled, it is expected to grow further 150 to 250% by 2050. To reduce emissions, IMO has set a target of 50% reduction of greenhouse gas by 2050. I believe through this seminar, we will get greater insight of whether current operational practices, policies, and abatement technologies would be able to meet the target. Now I would like to introduce our first speaker, Mr. Andrew Ong. Mr. Andrew is the regional manager of IMarEST Asia Pacific, and he is responsible for the development of the institute in Asia through developing program with governments, regulators, universities, associations, and private companies. His presentation is about how IMarEST can support your CPD, membership, professional registration, and distance learning programs. At the end of the presentation, we will have time for question and answer. Please do submit your questions through comment section of Facebook or YouTube Live. Meantime, I will hand over to Andrew to start his presentation. Andrew, please.
Thank you, Shakawat, and good evening, good afternoon to all of you. Thank you very much first of all, thank you BMCS for organizing this activity and having me and Dr. Colin to share from the IMarEST what we do and of course another technical topic. And I'm going to start my presentation very soon. Natif, would you please help to share the screen, please? Yes, today's presentation, it is about the IMarEST itself and how we actually support marine professionals and organizations. I will just first start off with the history of IMarEST. We actually started in 1889 in London. And it was originally a get-together session of marine engineers working on 4 different types of vessels. So it was more like a gathering of marine engineers to share some solutions or problems that they encounter on board vessels. And in 1933, the organizations was granted a royal charter from the British government and has become a chartered institute. So until very recently, we have changed the name of the institute from Institute of Marine Engineering to Institute of Marine Engineering, Science and Technology, which actually is our aim to provide multidisciplinary solutions or approach when we like to solve some issues we face in the marine sector. Currently, we have more than 20,000 members across 128 countries. And this is roughly where our 20,000 members are coming from. Majority of them would be from ports and shipping, offshore oil and gas, naval and defense sector. And we are having more and more members coming from the other part of marine sector, including marine science research, marine renewables, aquaculture, fishing, and general maritime services, including the commercial side, to join the institute. So this is not just because some friends and colleagues might have the impression that this is only for marine engineers, and this is not the case. As the name suggests, that it is actually for overall marine engineering, science, technology that can solve the problems we encounter in today's sector and the environment. This is the map of what we have in terms of offices and branches. We have offices in London and in Singapore, and I'm the one that is in charge of the Singapore office, in charge of the overall development of the institute and partnership with different types of organizations across the region. And the yellow flags that you can see on the map are our local branches, which are run by our members and they are funded by the HQ. So almost before the pandemic, roughly in every 1 to 2 months, there will be either a technical presentation or a networking session being held at these branches. And actually, if you can see earlier here in the map, we have a very active branch, local branch in Bangladesh. And I believe there are roughly 50 to 60 members that are actively participating in the branch activities, and I believe the number is increasing continuously. And last year, it was our great honor, together with the Nautical Institute, to award the Center of Excellence to Bangladesh Marine Academy, BMA. And I believe that all of you actually have seen some of the footage because it was probably shared by BMCS at the gala dinner last year. So now I will go quickly into the IMarEST offers. I would say IMarEST offers can be a bit complicated. It has a wide range of services, but I would like to break it into 3 parts. The first part will be on membership and registration, which basically is a range of benefits for members, and most importantly, the international recognition that engineers, scientists, and technologists can enjoy. Then the second part is the distance learning programs that we offer together with Plymouth University of the UK. And the last part will be on accreditation. That one is more for organizations, including the Navy, including schools, including private companies. But that is just to share with you what the 3 core services of IMarEST. IMarEST has a 4-tier membership structure that actually is to reflect one's seniority and also professional competency. It started off at affiliate and student member. So affiliate members and student members, they are the members, but they do not have the voting right. And for associate member, and fellow, these 3 categories are the voting members of the institute. And they are actually collectively, these voting members are the ultimate owner of the institute, which is a membership body. And one thing I would like to highlight is that the student membership the student membership that IMarEST provides to all full-time students, cadets, apprentices working in shipyard, all these professionals at their initial professional development stage, they will be able to get the student membership for free all the way until they have completed their study or their attachment. And they will then be able to enjoy the graduate pathway scheme, which we designed especially for young professionals to support their initial stage of career development. And there are many benefits of joining the institute. And these are a summary of the key highlights, including the Marine Professional Magazines, which is the Institute's own publication. It comes out bi-monthly. It covers all kinds of topics, including latest market trend, technology breakthrough, interviews, policy updates, etc. And then this membership benefit will also provide opportunity for our members to join the special interest groups. So these special interest groups basically are expert panel of our members that they will have all kinds of activities, from sharing knowledge all the way to submitting white paper at the IMO level. All these are possible options of special interest group. And some of the topics of these special interest groups include autonomous vessels, vessel repair and maintenance, ballast water management, biofouling, etc., etc. So these would be very good platforms for professionals who have a specific interest to actually join and to interact with peers with very similar interests. And Other benefits that I would like to highlight include the IMarEST TV, which is like our own YouTube platform, and we will have the technical lectures that would be put there. And I believe that after today's live streaming, we will also upload this session onto IMarEST TV so that our members will be able to see what we are doing tonight in Singapore. Then we also have a virtual library. We have local branches across the world. And all these are benefits for our members to enjoy. Then the other one that is, as I mentioned earlier, that the first part would be on membership and registration. So these are the membership benefits. And now I will talk about registration. You may have encountered some of your colleagues or your business partners that have a title called Chartered Engineer, CH, or Chartered Marine Engineer, CMAH, which is the post-nominal they use after their name. So these are the examples of professional registration which we can offer. And for engineers, the Institute can offer from marine engineering technician to incorporated marine engineer, all the way up to chartered marine engineer. And for our colleagues who are not from the engineering background, for example, deck officers, operations specialists, surveyors, even naval officers, etc., they will be able to go on this general technologies pathway, starting from marine technologies, registered marine technologies, to chartered marine technologies. So you will ask what these professional registrations are, or what exactly do they do, apart from the title itself. This is an example of the UK education system, which the Commonwealth countries follow. Usually for A-level, it is roughly level 3 of what we are saying. And for diploma, depending on the program, it will be recognized on this ladder at number 4 or level number 5. And usually for bachelor degree holders, it will be at level 6. And for master holders, it will be at level 7. You don't see level 8 here, but that would be roughly equivalent to PhD holders. So if you are a seafarer, you highly likely will obtain academically a diploma after completing your COC training session and the sea time, and you will have COC class 3, class 2, class 1, and to progress your career. But academically, you will still be at the level 4 or level 5, which well, in some cases, especially when the seafarer actually start working ashore in the office, they will need to have a higher academic qualification. So what this registration can do is that in the UK standard, the chartered engineer or the chartered marine technologist, the chartered level is equivalent to level 7, which is a master degree holder. So this is actually alternative of recognizing your competency and your skill set rather than just looking at a pure academic level. And so I have completed the membership and the registration part, and I would like to just explain roughly what this MLA College is. MLA College is the IMarEST distance learning education arm, and it offers up to master level education programs. It is in partnership with the University of Plymouth from the UK. In a nutshell, MLA College delivers the program in 100% distance learning manner, except for hydrography, which a short period of on-campus training is needed. But other than that, all other programs, you will be able to do it at 100% distance learning format with real tutor to support your thesis, to support your research, to support your coursework. And after you have completed the program, maybe after roughly 2 years or 3 years, depending on the level, the University of Plymouth will award the degree. So you will be completing a distance learning education program from a recognized university in the UK, which is quite well known in the marine sector. and you will be able to continue to work. You won't have any gap years. You will be able to progress your career at the same time your academic qualification. So this is an alternative that would be very ideal for seafarers or any professionals who cannot afford to go to a campus to complete their studies. These are some examples of our education offers, including master top-up for both marine engineering or navigation. It means that a COC Class 1 holder with at least 5 years of working experience as either chief engineer or master or a CO or a second engineer, they will be able to do a 1-year master top-up program from MLA College and get this master degree awarded by Plymouth University. And the first program that I would like to highlight is the Sustainable Maritime Operations, we call it SMO, which is available at both master and bachelor level. And these programs is, I would say, very popular in Singapore itself because it is recognized by the MPA and it is eligible for MCF funding, which will cover up to 70% of the tuition fees for Singaporeans and PRs. So if you are eligible for the MCF and you are looking for a master program or a bachelor program to do, and you would like to continue to work, you can consider MLA College because it will be the ideal solution for work and learn. And the last part would be on accreditation. So membership and registration together with the MLA College offering, those would be more for targeting an individual. So accreditation is something that we usually work with organizations. We provide to organizations. At the beginning, we already mentioned that the BMA, Bangladesh Marine Academy, has been accredited by the IMarEST and NI to be a center of excellence. And these are just some other examples of universities and companies, including Lloyd's Register, including Shell. All these organizations have seek different types of accreditation from us. So this is just a very quick presentation on the service of IMarEST, and thank you very much. And I think now we will be able to have some questions.
Yeah, thank you very much for your nice presentation and sharing information of IMarEST and various supports for the members. I would request you to share some information about what are the qualifications required to apply for IMarEST membership in corporate engineer and chartered engineer.
So there is no if you are a seafarer with a COC ticket, you actually can use the COC ticket to apply for the membership. But even if you don't have a COC ticket, you will be able to apply because the core principle of the IMarEST membership and registration we are trying to do here is that we would like to provide the appropriate level of international recognition to our marine professionals, regardless of their academic program, regardless of their academic qualification. So we would like to see whether we can benchmark one's expertise with their industry knowledge, with their working experience itself, rather than the certificate itself. So, yeah, I hope I answered the questions.
Okay, thank you. Then my next question is how IMarEST can help a member in continuous professional development?
It will basically be done by, the member will have as a member, they will have all kinds of access to our benefits and tools, including the magazine, including reading the journal, including joining some other webinars organized by different parts of the world, like this. The UK system is not a point system, unlike other parts of the world that they are taking maybe 40, 50 points a year that someone need to record and fulfill. The UK system is it is by record by doing it. So we don't calculate points. We don't need to collect CPD points, but we require someone to we require our members to actually record their CPD activities on a daily basis. So example of CPD activity can be, for example, attending a webinar, reading a very detailed report on accidents, watching online lecture, attending trade show or conferences, or even solving a very complicated project or case in your working environment. All these are counted as continuous professional development in the UK system.
Okay, thank you very much, Andrew, for joining us, and we look forward to arrange similar event with IMarEST in future. Now it's time for our second speaker, Dr. Colin. I would request Mr. Sharia to take over the floor. Thank you.
Good evening, members and everyone viewing this program. I'm Shahriar. I will touch on the background of the topic before introducing our second speaker of this evening. Biofouling of the hull begins within minutes of a vessel launch. Biofouling increases the ship's drag, which decreases speed and range and increases fuel consumption and greenhouse gas emissions by as much as 40%. In-water hull cleaning to remove biofouling on commercial vessels costs from $5,000 to $50,000 US, depending on the size of the ship and level of fouling. Frequent cleaning delays the voyage and cause off-hire. To minimize these negative impacts, the maritime sector relies on effective anti-fouling coatings. Copper is by far the most widely used active ingredients in anti-fouling coatings, and there are a limited number of alternatives. Our second speaker, Dr. Colin D. Anderson, will be talking about how fouling control coatings contribute to energy efficiency. Dr. Colin worked for International Paints for 36 years, starting in 1978 after completing his BSc and PhD degrees in chemistry at Edinburgh University. He spent first 10 years at IP learning about anti-fouling paints and was responsible for a number of collaborative R&D projects with Nippon Paints. He left IP in December 2012 and now the R&D director of American Chemet, the global leader in copper oxides for anti-fouling coatings. Please welcome Dr. Colin.
Thank you very much, and thank you to BMCS for this opportunity to share some of what I know about anti-foulings. Fouling control coatings exist in order, as we've had from introduction, to keep the underwater hull as smooth as possible. It's a means to an end. It's not an end in itself. So coatings are used for smoothness, for maximum energy efficiency of any vessel, regardless of vessel type. For example, an aircraft carrier has to be going at 28 knots for the aircraft to land safely. Container ships have a schedule to meet. ULCCs, the third picture there, that they have a big cargo to carry and they want the maximum cargo days, minimum time to delivery. And fast ferries, they need to go at high speeds. This one operates in South America across the River Plate, 57 knots. So anti-foulings are all about smoothness. That's really how they work. I'm going to tell you and describe to you the four main technologies that now exist for keeping hull smooth and thus increasing energy efficiency. Of course, it's not only energy efficiency that matters and smoothness. There's also an aspect of coatings, which I'm not going to talk about, which is transporting alien species, non-native species, from one part of the world to the other, which anti-fouling coatings or fouling control technologies play an important part in. I'm not going to talk about that. I'm purely referring to the energy efficiency side. Well, if we go back, this is 108 to 1882, a picture of how in the previous century, 2 centuries, ships used to be managed. The fouling was managed by careening the ship. That's where they put all the guns and all the people on one side, and they turned it on its side, and they got a whole load of people with scrapers to come and scrape and clean the bottom of the ship. This particular ship, you can see small plates near the bottom in the anti-fouling area. It became quite common in the 18th century for copper in the form of very thin metal sheets to be put onto these wooden hulls, and because it was discovered that copper metal in the form of thin metal sheets could be very good for controlling fouling. And indeed, the British Navy, the very first ship is shown there on the left, HMAS Alarm, was the first ship to be fully copper bottomed. And that's a phrase that's actually come to mean in common parlance. If something is in really good condition, it's supposed to be copper bottomed. That's where the origin of that phrase came from. And then in several of the Navy battles that were fought at that time, the British fleet had these copper bottoms, and their ships were faster and therefore speedier than some of those that they were fighting in. As that time came and steel ships appeared, and that was a problem for copper metal, because if you put copper with steel or copper with aluminium, you get a corrosion, a galvanic corrosion, electronic reaction, whereby the steel or the aluminium dissolves away and the copper is plated out. And because of that, copper metal couldn't be used. So it became changed into a powder form, copper oxide, red, which was dispersed inside a paint and isolated from the steel hull by an anti-corrosive primer. And in the early part of the 20th century, 1900s, anti-fouling paints technology blossomed. And after the Second World War, a book was published, which still has relevance today, published by the Woods Hole Oceanographic Institution in Massachusetts, called Marine Fouling and Its Prevention. And if you want to know about the very fundamentals of anti-fouling coatings, this is a good place to start. So that was what was happening around the middle 1950s. And at that time, the maximum lifetime that an anti-fouling paint remained effective was approximately 2 years before you had to either clean the ship thoroughly or take it into dry dock and repaint it. How was this achieved? Well, it was achieved by loading the paints with this powder form of copper oxide, and they also included other biocides. There were very few regulations in the 1900s, and you had mercury, arsenicals, organotins, lots of rather nasty chemicals were used, and they were added to the paint, and slowly the paint released them. They came to be called soluble matrix anti-foulings, and I'm going to be referring to that a little bit in this talk. And my thinking of them is like a bar of soap. If you take a bar of soap and leave it in the sink or the bath for a long period, or even quite a short period, it becomes very soft and mushy, and it disintegrates and dissolves away. That is what these soluble matrix anti-foulings are like. But instead of just being soap, they also contain within them these biocides, copper oxide or other biocides. As the oil industry developed and synthetic polymers became available, these were then added to these soluble matrix paints and became tougher and more durable. And paints of this type have become known as controlled depletion polymer, often shortened to the 3-letter acronym CDP. But they're basically together, soluble matrix, CDP anti-fouling is the same idea of dissolving out. Well, how do you control the paint dissolution? You don't want it just to instantly dissolve. You have to make it last a long time. And the way it's done is by using the fact that seawater is actually alkaline, has a pH of 8.2. And these paints work by having an acid binder that dissolves in water from basic chemistry. Acid plus alkali gives you salt plus water. So this binder dissolves in seawater, and as it dissolves, the biocides are released, as illustrated in that picture. So what is this acid binder? Well, it's a component called rosin. Now, rosin is a renewable natural resource, so it's sustainable. It's very, in our day and age, a very good thing to be using. It's often referred to as gum rosin or wood rosin, and you may well be familiar with it from some other aspects of life. For example, if you're a musician and play the violin, you use a block of rosin on the bow. It's rosining up the bow, it's called. Baseball, if you follow baseball, sometimes the pitcher bends down and rubs his hand in a white powder. That is rosin, because it gives you the ability to be a little bit sticky and get a good spin on the ball. Fireworks contain a lot of rosin. So rosin itself is a very common raw material and comes from trees. You cut the bark of a tree and it's a bit like rubber. You collect it in a little cup at the bottom, and then that cup is then rosin. In its dry form, it's a brittle, bit like a crystal, which shatters quite easily if you break it. This picture here is a schematic of how these paints work. You start with the paint, which got red dots, which are the biocides, in the binder, the rosin system, on top of an anti-corrosive primer. You put it into the sea and the water migrates into the film, and that then releases the biocides. They come to the surface and come out. And over time, you build up what's called a leach layer, a depleted layer at the top where there's no biocides, but the binder system is still there. This continues over time. And as this happens, the size of this top layer, the leach layer, grows thicker and thicker. And eventually the paint will fail because you can't get enough biocide diffusing through this leach layer to the surface. And that's why these paints actually have a limited lifetime, 3 years, 2-3 years at the most. If you look at the way that the biocide is released from these paints, this is a time versus concentration graph. And initially, when the paint goes in the water at time naught, you have a very high flush release of the biocide. Because that's as the water first goes into the paint. But gradually, over time, it falls down and down and down. And eventually, it gets to what we call a critical leaching rate, where if you go below that, fouling will start to settle on the ship. What is that level? Well, for copper, which is the most commonly used anti-fouling ingredient, it's about 10 micrograms per square centimeter per day. If you're above that, most fouling won't settle. If you're below that, fouling will start to settle. So that's the critical leaching rate for copper. This is a microscopic picture through a cross section of one of these soluble matrix or CDP anti-foulings. At the bottom, you can see a gray layer with some black flecks in it. That's an anti-corrosive paint, and the black lines, which are long horizontal lines, are the aluminium pigments which lie flat together to prevent water going through the paint. Above that, you've got two layers. One layer has a lot of red dots in it. That is the red dots that you see. That's copper oxide. And above that, you have a layer where there's no red at all, because all the copper is leached out of that layer. It's got a few holes in it, and it can become quite thick. This particular one is 75 microns, quite a thick layer. So that was the middle 1950s, 1900s. But in the 1960s, a big discovery was made that introduced a totally new fouling control technology, which is known as SPC, which I'll talk about. The way this was found was because one of the biocides, the boosting biocide used at that time, was a chemical called tributyl tin oxide. And it was found that you could chemically attach this to an acrylic polymer, and that this in seawater was slowly hydrolyzed, which is basically a chemical reaction. It reacted with the seawater at the surface. And so you could make a paint without any need to use this rosin that was previously used. The paint itself was very hydrophobic, so water couldn't go into the depth of the surface of the film. It only reacted at the surface, which means that you get much better release of the biocide. The first paint of this type was introduced in 1974, and it was given the brand name SPC1, or Self-Polishing Copolymer 1. That was purely a marketing branding name. But over time, because the technology was so good, this term SPC, another three-letter acronym, became the universal term for this technology type. So how does it work compared to the previous one? Well, when the paint goes in the water, as I said, only the surface reacts with seawater and becomes soluble. And so that's the yellow line I've shown you there with the biocides. Over time, the surface dissolves, it becomes soluble because hydrolysis converts it from a non-acid to an acid polymer, and the thickness starts to go down, it starts to dissolve, but it the dissolution only happens at the surface, and over time it reacts, continues, and the film is getting thinner. That's where this term polishing was used. It's lowering the film thickness, and eventually the coating fails when there's no paint left at all. It's not because there's biocides still there which can't get out. There's nothing there. And that's how these paints work. In terms of the biocide release rate, I showed you previously how the soluble matrix CDP release rate works, and what's called an exponential release. Starts very, very high and ends up quite low. With these SPC paints, completely different release rate. You have an initial setting up where it starts a little bit high and then falls down, and then it carries on in what's called a continuous release rate on a very steady level, and it only fails when the paint completely disappears and can go on for a very long time. This is a cross section through one of these paints. The red color is the red cuprous oxide, the copper oxide. On the top at the left, you've got a non-polishing reference where the seawater hasn't been able to see the surface. But on the right-hand side, you can see it's dissolved away. The dotted red line is where the paint used to be, but over time it's dissolved, dissolved, dissolved. And right at the top of that, you can see a very thin white layer, which is the leach layer. Usually it's around 10 microns, very, very thin, less than 25 anyway. And that is how these paints work. It's a controlled release of biocide with a very thin leach layer on top. If we look at the comparison in terms of some of the performance attributes, these SPC paints were revolutionary in that ships could now start dry docking only every 5 years, whereas previously you could never get much more than 2.5, 3. So that was a big benefit to ship owners, because if you did an interim inspection for your insurance in water, you didn't need to dry dock for 5 years. The films of these SPC films are 100% acrylic polymers, so that they're hard and tough even when they're dried out, whereas the SPC paints can be cracking and detaching. A big benefit is the surface roughness. Way back at the beginning, I talked about anti-fouling paints are all about smoothness. And with SPC paints, you get a decrease in roughness. And I'll show you that in a second. Whereas with the soluble matrix, because they flake and they're not very good mechanically, you get generally an increase in roughness. And when it comes to maintenance and repair, SPCs are very simple and easy. You just wash it and recoat. Whereas with soluble matrix, you probably have to do some sealer coats or touching up, and a lot of extra work is required. This is a series of pictures illustrating the polishing process. This was a soluble polymer in a flow channel, and the blue arrow shows the flow of water going over the surface. Starting on the left-hand side, you've got quite a rough surface with peaks and troughs. Over time, this gradually, as the water moves over, it smooths it, and eventually, after a period of time, it becomes extremely smooth. This is what happens with these SPC paints. They actually get smoother as the ship goes through the water. And in the 1970s, 80s, this was a revolutionary thing. When a ship coming into dry dock with one of these SPCs, and this is a typical SPC ship. Those of you who are in the marine industry will recognize the very light blue Maersk color. This was a Maersk ship. And it's got these, if you're not familiar with them, very strange zebra-like patterns on the underwater area. The boot top was a non-anti-fouling. It was a red inert paint, and you can see it's picked up quite a lot of weed fouling, quite extensive weed fouling on that red area. But underneath in the blue pink area, there's very little fouling at all. What is this polishing effect, where does this come from? Well, it's purely a reflection of how the ship was painted. As you probably know, when a ship is painted underwater, in the underwater area, cherry pickers go up and down with one, probably two sprayers spraying, and then they move along and then they go along, and where they overlap the spray gun, you get thicker paint. Originally, this ship was completely the pink red color, and in the thick areas where these sprayers have overlapped, you've still got that color. But in the thinner areas where the sprayer is in the middle of the spraying, you've gone through to the second underlying coat, which in this case was a blue. If you look at it schematically, you start with this, the polishing of the surface goes and the thick areas still remain. If you look vertically down on it, you've got these gray pink colors. And here's another ship with a typical SPC type pattern. And if you see a ship coming into dry dock with that pattern, you know it's one of these very well controlled self-polishing anti-foulings. This is a flake that had a very rough piece of anti-corrosive underneath. And when it was first painted, it had 4 layers of white gray SPC paint on the top. Underneath that, there was a pink anti-corrosive primer. And you can see on the top of the peak there, the top 2 coats nearly have polished away, and you've just got 2 remaining. Whereas in the valley on the right-hand side, you've still got nearly 4 coats. So you've gone from quite a rough surface, and it's smoothed out on the peaks and valleys. What effect does this have on fuel consumption? Well, this is a graph showing increase in fuel consumption over time for 2 identical sister ships on identical routes. And it shows a comparison in the fuel increase over time. Generally speaking, all ships increase in fuel as they go through service life due to many things. It can even be just mechanical damage because the surface can get rougher. But for the first year, 12, 15 months, these 2 paints behave very similarly. But at 15 months or so, the CDP, the soluble matrix paint, suddenly started to pick up fouling because there was not enough biocide coming to the surface, and the fuel consumption shot up 7-8%. Whereas the SPC paint just gradually over time increased up to 5 years. So that's the major big benefit of SPC. Now, that was fine in the 1980s, but up to the 1983, the active that I talked about, tributyl tin, was found to be a problem. It affected non-target organisms, oysters, snails, and very quickly they actually got banned for use on pleasure craft yachts. It wasn't until October 2001 that the IMO managed to pass a treaty to ban their use, and this was called the International Convention on the Control of Harmful Anti-Fouling Systems on Ships, shortened for convenience to what's called the AFS Convention. From 2003, you weren't allowed to apply these TBT paints, and from 2008, no ships were allowed to have them on. And interestingly, this same convention has been used to invoke a ban on another biocide, which is found to have an environmental negative impact, ergorol 1050 or Sibutryne. So since that time up to the present, all the marine paint companies have introduced TBT-free SPC technology, seeking to mimic the performance of the previous very effective TBT. The ones that are now available on the market are all acrylic polymers, and they have side chains attached to it, like TBT was attached to an acrylic polymer, which can either be a copper acrylate or a zinc acrylate or a silyl acrylate. And one company has an ammonium sulfonate acrylate. These all react with seawater. The copper or zinc or silyl comes off, and you're left with an acid polymer which dissolves, an SPC performance. These couple of pictures showing how these can work. They can work well. The one on the left is a silyl acrylate SPC system, and it's got these zebra-like polishing patterns you can see. The one on the right is a copper acrylate SPC. Again, you can see these polishing patterns. If you look at price performance between these two technologies, the performance on the y-axis high to low and the price low to high on the x-axis, the SPC products tend to be higher performance, higher price. The CDP soluble matrix are lower performance, lower price. And in between that, you have a number of other technologies which marine paint companies have introduced. But these are the two main ones. Just a quick mention about biocides. Biocides are used in these paints, and they are, however, extensively tested in order to ensure human and environmental safety. You can't just put anything in like you could in the early 1900s. In most countries, you have to register these products, and the number of products that are registered is very limited. Copper is the main biocide still used. It's a natural product. It's present in seawater. We all have copper in our bodies, and it's likely that this will continue to be used for many years, as long as it's not in excess. It's like anything, excess of anything is a bad thing. Too much copper is a bad thing, but the right amount is perfect. There are other boosting biocides registered for use, but overall the choice is very limited. It costs a lot to develop a new biocide for the anti-fouling market, millions of dollars to register them. So I suspect it'll be a long time before any new ones appear, if at all. So let me move on now to the third type of fouling control, anti-fouling. And these are what are called fouling control coatings without biocides. There have been many attempts, a good many attempts, to control fouling without the use of biocides. And there are many suggestions and ideas that have been tried, but there are only two technologies that have had any commercial impact. One is what are called foul release or fouling release coatings, non-stick essentially, like non-stick frying pans. And the other is what I call coating plus cleaning technologies. In general, these have been restricted to certain vessel types and operation profiles. And at the present time, they make up less than 10% of the overall market. The previous technologies I'm talking about, the SPC and CDP, they're about 90% of the market. These are less than 10%. It's interesting to look at how these were discovered, because it's actually a complete accident. In 1972, a gentleman by the name of Alex Milne, he was looking at some TBT containing rubber panels from Goodrich, the tire company, on test rafts, and he put these on these rafts and he fixed them in place using a silicone sealant, like you would use around the edge of the bath to stop water going down it, or the edge of a shower tray, or behind a sink, just a straight silicone. And he used that to secure these towels in place. And he found 6 months after immersion that the Goodrich rubber panels, which were full of TBT, had actually failed, whereas the silicone around the edge was completely clean. And being a good inventive chemist, he didn't just throw the panels away and say, well, that's a pity. He then developed the silicone and patented it. But the technology was kept low key for more than 10 years because almost at the same time, that new SPC technology was being developed. And it was only when the issues with TBT arose in the 1980s that this silicone technology started to be looked at more thoroughly and practical systems developed. A big advantage of any silicone paint, but these in particular, is that when you freshly apply them, when they're first applied, they actually have a very smooth surface. And that's what anti-foulings are all about. And this is a laser scanning profilometer, surface profilometer of a silicone system on the left. And this shows the colors show the different heights. And on the right, with a much bigger scale, in fact, are the SPC anti-foulings, much sharper peaks and much rougher. Now, the SPC does smooth with time, so it's not a true comparison. But from day one, these silicone systems can be very smooth. This is a picture of a silicone system applied on an LNG ship. And here are a couple of guys in a cherry picker measuring the surface roughness. And you can see their reflection very clearly in the paint because it is very smooth. normal anti-foulings, the ones I was describing earlier, have a very matte finish. They're not glossy at all because they're full of pigment, biocidal pigments. Whereas these paints have very low pigment concentration and therefore are very smooth and glossy and have a high gloss. The way they work is the basic non-stick principle. This was a boat in Venice that did actually, a few barnacles did attach to it, but when it came into the dry dock, it was very easy with a simple hand just to pull the barnacles off. Normally, barnacles stick very aggressively, and if you try and remove them, you not even cut your finger. You usually leave the base plate, the white plate, behind. But you can see this guy, when he took it off, the whole thing came off because it's a non-stick surface. Here's a ship operating. It's a small ro-ro operating out of Port Everglades in the US to the islands in the Atlantic, and it came in after 5 years in the condition shown on the left-hand side there. Quite a lot of slime on, but no barnacles, no weed. And after washing, you restore the surface back to where it was before. So that's a 5-year dry docking. And that same ship actually went 10 years. Silicones are very, very durable. Silicon oxygen bond, sand, it's the most strong bond on Earth. So it's very durable, these coatings. This is a 10-year. You can just see the guy wrote 10 years on it in the right-hand picture. But this also illustrates a couple of problems with these coatings. This ship actually went over a sandbar when it was trading, and you can see on the right-hand side that it's actually scraped all the paint off to the red primer underneath. And at the top right of that picture, you can see where it's been scraped off. There's actually a white area, which is in the middle, which is covered in barnacles. So these, if they get damaged, they completely lose their efficacy because they're purely relying on the physical surface effect. So if it gets damaged, it's a problem. This is a car carrier after 3 years, and it compares the SPC in the boot top area with the fouling release on the underwater area. And you can see both have worked well, and they have very comparable performance. In this particular case, the SPC was put in the boot top area because that's where you got rubbing alongside when it was tied up along the pier. And so just having the silicone underneath that meant it didn't get damaged, because that's what can ruin the performance. This is an LNG ship in Dubai after 30 months. The bow wave had gone right up over into the boot top there, and you can see it's covered in that green anti-fouling, whereas the fouling release underneath has worked extremely well. So they can work extremely well, these foul release coatings. The final type I'm just describing to you is something that is been a flurry of activity recently, and I expect more and more, which is looking at cleaning to go alongside coatings. Cleaning technology used to be a very basic science, and usually Navy divers or ex-Navy divers would take steel brushes and they would scour the surface, and it could be very damaging. Now, because of all the investment in cleaning, there are various companies, and I'm illustrating two here. One is called Hull Wiper. This uses water jets on an underwater robot to go over the surface and clean any fouling off. And similarly, a company called EcoSubsea from Norway, same principle. They have a robot which works underwater. This one uses rotating brushes, and they collect all the detritus that comes off. So cleaning can be a very helpful addition to coatings, and I expect it to become more and more as we go forward in time, especially when we have such as has happened this year because of COVID. Ships have changed their operating patterns in totally unexpected ways, and many have had to be laid up. And when you're laid up and you're not moving, the anti-fouling can lose efficacy quite rapidly. So being able to have a good cleaning system is very good, because then you can go back into service without having to dry dock, without having to suffer the penalty of fouling. It's not entirely without care that has to be taken. You can't, if you damage the coatings, that could be an issue. You don't want to release any non-indigenous species in unwanted areas. I refer to that as one of the benefits of anti-foulings. And if you can have a clean a system that captures everything that comes off the ship, that's how you stop that. And that applies also to any harmful chemicals. You don't want to be releasing chemicals into the sea in a big way. One aspect of cleaning is a term that's come to be called grooming. This means very light cleaning. You're hardly touching the surface. And if you carry this out, and it's to be carried out before any macro fouling starts. It's a term that's not been developed. It's a system that's not been developed greatly, but it is starting to be developed. And interestingly, the Norwegian paint company Jotun has started promoting a small robot to do this. And I like to finish just by reading what they say about it, because this illustrates what I think could be the future of anti-fouling or fouling protection. Systems like this. The Jotun hull skater, which utilizes magnetic wheels to cling to hull vessels, works to remove bacteria and biofouling before macrofouling grows. At such an early stage, fouling can be removed without risk of damage to or erosion of the coating. Not only delivers peak performance and unlimited idle days for ship owners, minimizes the need for reactive cleaning, cutting costs, environmental risk, and optimizing fleet flexibility. And this is the little robot that they promote with it. It hasn't penetrated the market much yet, but it illustrates what might be the future, where every ship could have its own little robot, and when it stops, it could keep the hull clean at that particular time. It's just a vision of the future, I think. So that's my presentation. I hope I've given you some insight into the world of keeping hulls smooth for energy efficiency. SPC types, the high performance soluble matrix, not so high but effective, fouling release, coating and cleaning. And thank you again to BMCS for this opportunity to talk to you.
Thank you, Dr. Colin, for your very informative presentation. We are sure that our members have benefited and will be able to take a more informed decision while selecting anti-fouling coatings. We will now show BMCS video for about 5 minutes. Our third speaker of the day will be presenting a very interesting topic after the video. Please don't go away. Thank you.
Having a long sea coast at the Bay of Bengal, Bangladesh is well known as a maritime nation. Over 90% of its goods are transported via sea and waterways. This makes shipping and prudent seafarers most important factor for the development of the economy. Bangladesh Marine Academy is the home of most of the Bangladesh mariners. Marine Academy was established in 1962. Long 57 years of professionals' developing journey is now moving ahead, more with coveted international standing, achieving name and fame of developing world-class maritime leaders. Yearly, average recruit of cadets, pre-sea, 120 cadets, male and female. Number of trained post-sea officers, 30,000 marine officers and marine engineers. Located in a beautiful picturesque surrounding on the large green hills and valleys at Juldia Point of Chittagong, where the river Kornafuli meets the Bay of Bengal. In recent years, Marine Academy achieved recognition of Nautical Institute, London, and Institute of Marine Engineering, Science and Technology, London, and also upgraded its status as a partner institution of World Maritime University, WMU, Sweden, envying others. BMCS, Bangladesh Marine Community in Singapore, is a professional organization registered under Registry Societies, ROS, Singapore. BMCS vision: to work with any other organization having similar interest for marine community and work for professional development and shared value creation towards sustainable maritime operation. BMCS mission: We are professional mariners, share our professional knowledge, exchange professional ideas, and promote social welfare. It is a socio-cultural family organization to build a strong bondage and promote brotherly and cordial relations among all mariners living in Singapore. To promote social interaction and welfare of its members and their families. To promote professional interests through networking and a high level of ethical practices. Present Executive Council of BMCS. Recently, Sheikh Hasina Wazir, Honorable Prime Minister of Government of the People's Republic of Bangladesh, has paid an official visit to Singapore. The BMCS team held a meeting with Major General Mia Mohammad Zainul Abidin, Military Secretary to the Prime Minister, and Shipping Secretary Mr. Samad. They have discussed amongst other on seafarers' visa and landing permit related issues. We are fortunate to have more than 250 Bangladeshi mariners working in Singapore in renowned shipping companies, MPA, PSA, and various classification societies, etc. In fact, all facets of maritime business. All our members are surely committed professionals in the respective shipping companies or organizations, maritime or bunkering related regulatory bodies for which we all are proud of, meet regularly to exchange ideas and enhance each other's professional acumen for better marketability. We have created strong bonding among the members, though various activities such as technical seminars with expertise on maritime-related field, promoting healthy lifestyle activities, self-awareness of health screening, various sports activities, and family gatherings. We are committed to contribute more towards the maritime field with our dedication and sincerity. At the same time, we would like to extend our full support toward the Maritime Singapore and World's International Maritime Center.
Thank you very much for watching BMCS video. And now it's time for Mr. Ronnie, who is our last speaker. And I would like to highlight some key achievement by Mr. Ronnie. Abu Hassan Ronnie is an energy efficiency manager at Eagle Star Marine Technical Services in Singapore. He is an ex-chief engineer with 16 years of sailing experience on board tanker vessels. He has completed his PC training from Bangladesh Marine Academy. Apart from obtaining his certificate of competency +1, he has completed his MSc degree in maritime energy management from the World Maritime University, Malmö, Sweden. Currently, he is pursuing his PhD under Faculty of Engineering at the University of Technology, Malaysia, where he is actively working on green and sustainable shipping. Since early 2018, he has been engaged in monitoring the energy efficiency performance of tankers in Eagle Star. I hope you will find the presentation informative and enjoyable. Ronnie, please.
Good evening, everyone. Thank you, Mr. Shakot, for a nice introduction. And thank you, BMCS, for giving me this opportunity. I will focus on the energy efficiency. You know, my background is, lately I started working on the energy efficiency last 2 years. I will focus on this. My topic is coping with the IMO GHG target, ship owners' perspective. As you know, there are a lot of focus from the international authorities to improve the energy performance of the vessels by IMO. IMO set target, very stringent target for 2050 and 2030. So these targets is creating a lot of investment from the ship owners' perspective. So I would like to focus on this. Sometimes we do a lot of operational thing, and we miss so many things. Like small thing can create a lot of effect in the energy efficiency area. So that we miss, and it need to be improved so that we can improve the energy efficiency of the vessels. The butterfly effect. Small changes in some area, it can affect very largely on some other place. So small changes in the management or little initiative in the onboard vessels, or in the awareness in the office managers, it can create a lot of difference in the ship's fuel performance. I will my focus area today is the GHG reduction targets, how the targets is happening and from where it is coming, and what is the IMO target now, and the measurement metrics. What are the measurement metrics? So how do we measure the energy efficiency of a vessel, and what does it interpret to the sustainability of the ships? And lately, what are the facts happening? What are the measures IMO has taken to improve the energy efficiency of the vessels, and how it is influencing our vessel performance at sea? And lastly, I would touch upon what we could do about this. Every nations in the world, they have like 190 countries. They have committed that they will combat the CO2 emissions, and they will reduce their GHG emissions in the United Nations. So, being a part of the United Nations, IMO has its own target. That's why from the 2012 till now, there are a lot of pressure and a lot of energy related regulations has been developed in the IMO, and a lot of in the state, lot of measures are taken to reduce. And maritime area is not is not left alone. IMO has taken drastic actions to come in line with the 1.5 degree global target. So, keeping the sustainability in mind, we have to understand what is the sustainability means. Sustainability means doing some activities without hampering the future generations activities. We should not do anything that hamper the life of the future generations. As we have to run the economic activities. We cannot stop this. And the shipping is the number one. It considered as the backbone of the global economy. It emits around 2.8% of the global emissions. It is compared to other mode, it is very less. But if you do not control it, it is going to increase by 50% to 250% in the by 2050. So keeping in mind, so IMO has set the target to reduce the absolute emissions. Like the business will grow. We cannot stop the business, but we need to reduce the emissions by half, so that our global target is met. We can achieve the global target. So you see, so this is a very stringent target to meet. We do not have we need a lot of resources and a lot of research on this. So the To reduce the emission by 50%, we need the new technology. And as IMO have the global target, the 2030 targets by reducing the emission by 40%, but the carbon intensity need to be reduced by 40%. So this is a very stringent target to achieve for a ship owner. We know that environment and the energy efficiency go hand in hand. So according to the global goal, whenever environment is considered, energy efficiency also considered, and a lot of environmental activities are related to the energy efficiency. As you know, the MARPOL, there are a lot of regulations in the MARPOL to control the environment, air pollution, energy efficiency, and the GHG emissions. Recently, we have come up, we have faced the 2020 sulfur target. So the sulfur cap has, it come a very big burden of the to the ship owner, and to create this sustainable shipping and a lot of other regulations, it come by the IMO. So now, as energy efficiency is concerned, how do you measure the energy efficiency of your vessels? If you want to measure the energy efficiency of vessel, there are a lot of indicators introduced by the IMO. We have the energy efficiency design index for for the new vessels, and for the existing vessels we have AER, which is recently introduced by the IMO, and the IMO 4th GHG study also mentioned that. And we have the Poseidon principle, by the 18 financial organizations, the bank, and other parties. They come up with the Poseidon principle. It requires calculation of the energy efficiency to be calculated, and it measured, and it need to be calculated, and it need to be compared with the IMO trajectory. So here we have there are 3 indicators I put here: annual efficiency ratio, annual energy efficiency propulsion index, energy efficiency operational index. So this 3 indicator is calculated to calculate the carbon intensity of the vessels, how much gram CO2 is emitted per ton nautical mile. There are 3 indicators. These indicators, one is measured on the deadweight of the vessels, another one is the displacement, and another one is the cargo weight, how much cargo is carried. So there are some limitations in the indicators. Annual efficiency is calculated over the deadweight. So our ships are not always loaded, and the lacking of the energy efficiency propulsion index is it is calculated on the displacement. No cargo has been taken into account, but it can give us the closest performance of the vessels. Lastly, energy EOI is mentioned in the IMO SCMP, and the last GHG study also mentions the AER and EOI. Now you see the trajectory, IMO trajectory, how it will go down, how the carbon intensity is targeted to reduce by 2050. We can see that in 2008, the total carbon emission was 921. In 2012, it will be 960. It became like 962. In 2050, we have to reduce by 461. So that is a very big target for the ship owners. But there is some good news. We can see that the carbon intensity has been improved between the 2012 and 2018. The overall carbon intensity has been better since 2008. You know, the ACMP has come in 2012. So it has actually done a very good job, and now we're building like ship 30% better than the what the ship was in 2012 or 2008. There is one more aspect I have put here, which is the global emission has decreased from the 2019 now April 2020. I don't know, maybe this is because of the COVID, but the global emission has been decreased. Now we need to see as you're talking about the sustainable shipping and the zero emission vessels, how we can achieve that. So there are like, you know, technical options available and operational measures, and we have the greener alternatives. But we do not need to forget that there are some focus areas like, you know, energy efficiency technologies and operational best practices, which can contribute to a larger savings. And you can have, you know, the human element. This is not to be forgotten. The financial organization plays a very big role for the shipping. You know, putting the new technologies on board. All these initiatives by IMO, EOI, EDI, AR, and all this are to influence the ship owners to get a alternate. I mean, technical good technology integration to the vessels, which is a big part, and which is actually big pain for the ship owners. But we cannot. I don't think we cannot escape this. By 2030, we have to achieve 40% carbon intensity reduction, right? So this is a big thing. And you know, the EDI is a measure for energy efficiency for new vessels. As you know, that we are building efficient vessels, 30% efficient vessels, since we have done it in 2008 to 2000 to 2010. But in the 2030, if we want to achieve 40%, we need to have water measures, technical options, operational and greener options. We need to follow. We need to put on board ships. So let's see what technical options we have. We need to improve the hull and propeller efficiency, propulsion efficiency, because most of the energy is wasted through the hull. As you see that Mr. and Colin has presented the paint. And paint is a very big contributor to the energy efficiency. The efficient paint of the vessels can save energy like 9 to 10% in operations within like 5 years period. So hull coating is a very big factor, and we can consider like PID. PID is the propulsion improvement devices, which is fitted on the hull or in front of the propeller or in the propeller or after the propeller to reduce the flow. I mean, to increase the flow to the propeller, and streamline flow should be there to the propeller, which can save a lot of energy, of course, and consumptions come down. We have the hull design optimization. This is a initial stage. It is decided to optimize the hull to get a slender body so that the fuel consumption is less. Then we can consider the retrofits. Hull retrofits, like the shape of the bulbous bow can be changed, and it can reduce the wave resistance of the vessels. The propeller retrofits can be like propeller boss caffeines, fuse duct, in front of the propeller. We can fit like the flow improvement devices. Recently, some interest developed for the air lubrication system. There are under the hull we can pump air, so it goes to the hull. When a ship is sailing at a certain speed, it can reduce the frictional resistance from the bottom of the hull, and it can reduce the fuel consumptions. But it can improve the frictional resistance very high, but there is a concern that it needs a very big compressor, which takes up to like 2% of the fuel, 2% of the power of the vessel. So you need to install a big compressor, which takes up a lot of power from the ship's grid. So this, like if you consider a life cycle or a full life cycle analysis, how much savings it can give. I mean, it can be like 2 to 3%. Well, and then there are like hybrid solutions, battery solutions. Battery technology has recently improved, but the density of the energy is less. We need a lot of investment on this. So maybe it will not be a choice right now, but it needs to be improved. The technology is not mature yet. Recently the uptake of the renewables on the vessels has improved a lot. We have the solar panels on board ships, so that it can help. It can reduce the hotel load. The wind sails. So that there is some prototype at some of the Mark's One ship. They have invested on the flattener rotor. Some of the ship owners, they are thinking to put the kite. There are a lot of interest in that. But one thing we have to see that this technology cannot be implemented everywhere. The certain region, the speed of the ship. We need to see the wind speed. How much is the wind speed, so that it can give us the saving. If the ship is sailing a very short voyages and all this thing, it may not be applicable. And the next is energy efficient lighting. Many of the ship owners, they are changing their light bulbs to LED lamps. It gives not much, but maybe some savings on the hotel load, right? Then we have operational measures. Operational measures is actually sometime neglected. We need to have the monitoring and alerting of the vessel so that they can contribute to the saving. Then the next is the hull cleaning. We need to have a system. Maybe we can have like frequent hull cleaning based on the monitoring of the ship's hull. We can send alert to the vessels so that they can plan, and we can plan from the office that maybe regular, like 6 months, every 6 months we can clean the hull, so it improves the fuel performance. Around 6% of the fuel can be saved through the hull cleaning and the propeller polishing, and moreover, we can have the voice planning, weather writing, speed management. Speed management is one thing that can give us 27% of the savings. Recently, there are talks in the IMO, which they are thinking to regulate the vessel speed, so that when a ship is going at a lower speed, it consumes very less fuel. So if you can reduce the speed, it will give a lot of savings, and it will improve the energy performance of the vessels, and we can comply with all the indicators. Okay. So another thing is that we're talking about the zero emission vessels. There are green alternatives. Mostly, if we think about the zero emission vessels, the first will be the hydrogen fuel cell, and if we talk about the 2050 zero emission vessels we want to achieve. So hydrogen may be the one solution. After the hydrogen, there is in the second category we can take the ammonia. In the third category, we can take the biofuel, which will reduce drastically, around let's say 30 to 40% reduction can be achieved by the biofuel. Recently, there are some, LNG. LNG is actually it reduces a lot. Around 16 to 25% of the emission can be saved by the LNG directly. So there are a lot of interest on the LNG from the ship owners. LNG is actually considered as a transitional fuel. It may not be the solution for 2030 or 2050, but it can give us some time to buy so that we can slowly adopt the new technology and we can move ahead for the zero emission vessel dream. So there are some facts recently happening in the maritime area. The climate alignment need to be done for the for our every ships, maybe our fleet. What are the performance of the energy indicator like EEI, EOI, EDI, or AER? We need to calculate, and we need to see. We need to see where we are on the trajectory of the IMO 2050 goal, so that we can plan for our vessels and for our fleet for the retrofits, like for a vessel like 5 years old vessels. In the 2030, you will, of course, it will run. We have to run that vessel. So if we want to run that vessel in 2030, we need to plan ahead that when and what retrofits we are considering for that vessels. In the 2030 is not very far, I say, because already 2020 is gone, and the EEDI phase 3, like 30% reduction target before it was 2025. Now it has, IMO has preponed the EEDI targets to 1st January 2022. So there is not much time. So we need to actually plan ahead, and we can think what are the retrofits can be possible for our vessels if we want to run after 2025 or 2030. 75% of the carbon intensity reduction are just hybrid options or total shift to alternative fuels. 2050 targets, it cannot be achieved with the business as usual. 70% of the carbon intensity reduction need to be obtained by the alternative fuel or technological integration and invention. IMO may put the carbon tax in place. So it is evident that in 2018 there are some parties they have submitted to IMO. Maybe IMO will think about the market-based measures such as the carbon tax. Speed reduction, as I said, it was actually proposed by BIMCO and the Japan government. So there was talk on the IMO. So they may have put a bar on the speed reduction so that like 20% or 25% targets can be met by the vessels. But this speed reduction is one thing. It is actually not depend on the ship owner. It is like the charterers and other parties also involved, and it will reduce the capacity of the international trade. If the ship is running slow, there are less cargo will be transported. So everybody has to come together to put this in place. Operation and monitoring and alerts to operator can improve the energy efficiency about 1 to 2%. So we need to monitor the vessels regularly, and daily alerts can improve 1 to 2% of the vessels. And moreover, it can improve the vessel awareness, the ship staff's awareness, so that they can contribute to the initiative what we take from the ships. Many of the major required joint initiative from the stakeholders such as charterer, financial organizations, ship owners, and ports. As I said, the charterer is very important, and some ports are uh, taking the actions, and sometimes they are cutting the levies and promoting towards promoting the energy efficiency. So this type of initiatives is required to promote the energy efficiency. Right, to achieve the net zero, we need technical innovations. Lack of technology is a major barrier for decarbonization. So, as the stringent regulations are upon us, we cannot avoid this. What we can do about that? So we need to act responsibility. So to the climate, to the environment, everybody has the responsibility. So we need to act responsibility to our mother nature for the future generation, to promote the energy efficiency in our daily activities, right? uh, Adopt energy efficiency in the organizational short-term and long-term goals for better alignment. So towards achieving the IMO goals, we need to have the organization short-term and long-term goals, so that we are not left behind, and we need to actually now measurement, monitoring, and control. We may, as an organization, we can actually subscribe to the ISO 50001, which will give a which will give a better systems to monitor energy performance of the ship, and our systems will have a continual improvement we can achieve by the system implemented in our company. We can promote investment on the green technologies and digitalization, as you know, the IMO has implemented the IMO DCS data collection system in 2019. Similarly, in 2018, UMRP was put in place by the EU Commissions. So this has a drive for data collections and digitalization of the ships. So we need to put in place all these things. We need to educate our crew and create awareness among the vessel crew and other parties involved. We need a regular training and briefing of the ship staff so that they can contribute to the energy efficiency. We can share the best practices for improved energy efficiency. We can collect the best practices from the savings for auxiliary engine, how should we operate the boiler and the main engine, and we can share the best practices to the ship's crew, and they can contribute to the energy efficiency drive. Incentives to crew, this is one thing that we can consider, we can give to ships staff, if they can come up with the idea for efficiency improvement ideas, so that we can offer them some incentives so they can contribute to the energy efficiency in the organization, and it can improve better performance for the vessels. And as a whole, we can get the target achieved from our organization and IMO targets. So that will be the end of my presentation. Thank you very much.
Thank you so much, Ronnie, for your impressive presentation on energy efficiency management on board and future alternative fuels and deployment of zero-emission vessels for sustainable shipping to cope with the IMO GHG reduction target and to align with the 1.5-degree Paris climate goal. May I request Mr. Sharia to start question and answer session for Mr. Colin and Abu Hassan Ronnie.
Thank you, Mr. Shakwat. There are a lot of questions from our members, and hope we can utilize this time efficiently to answer all their questions. So I request Mr. Colin and Mr. Ronnie to answer the question in brief, so that we can cover as much as possible, as many as question possible. Okay, we have one question from one of our member, Engineer Riaz, to Dr. Colin. The question is, one of the biggest challenges these days are, despite being used high performance paint scheme, hull gets fouled if for some reason vessel idle days are more than specified by the paint scheme. Any new development or better insights? Dr. Collins.
It's very difficult to get rid of fouling once it starts, and without cleaning. Cleaning is really the only option you have if the vessel has changed voyaging pattern and has become fouled. There are no new developments in the paint side. The development has all been on the cleaning side, and there are much better cleaning systems now than there used to be 10, 15 years ago. That don't damage the hull, etc. So all the development has come in much improved cleaning.
Thank you. We have a next question to Mr. Ronnie. You have said about that some of the financial organizations, 18 of them, has come out with some program to monitor EDI or EIB of the vessels or the companies, to maybe for giving credit to those companies or ship owners. Okay, so in that perspective, what are the benchmark of EDI or EIB which the companies are proposing, so that they will support those ship owners or ship management companies? Mr. Ronnie, please.
Yeah, thank you for the questions. Yeah, this is actually came up new. This is called annual the Poseidon principle. It has been introduced by the 18 banks and lenders who give the money to buy ships or build the ships. So in this case, they need to know what are your vessels are doing, existing vessels are doing, and what is your energy performance, and it will be included in that financial portfolio. So that every ship owners, they need to measure their ship's efficiency in the basis of the indicator called AER. So recently in the IMO GHG study, fourth GHG study, IMO has also mentioned, as I explained earlier, it's called AER, annual emission ratio. It is calculated over the deadweight. What the ship is actually thought that always loaded, and it does not consider like cargo. So it can normalize the data, and it can measure the efficiency of the vessels, and it can compare with the other vessels like the benchmarking. So we need to improve. They have set the trajectory according to the IMO trajectory, 2050 trajectory, like 50% absolute emission reduction and the 70% of the carbon intensity reduction. So AER comes with that. By 2050, 70% reduction need to be done. So how we to achieve? How we need to achieve? We need to improve our EDI, and with that, we need to improve the operational efficiency and the operation of the vessels to contribute to that 70%.
Thank you, Mr. Ronnie. We have a second question to Mr. Collins. We know that he has been in R&D and he has been in commercial, and also heading this marine division in IP. So it's a very question is like, when you're developing a new paint scheme, you need to think about toxicity as well as its efficacy and also the price. Okay. So as a R&D director, how you balance all these three? Collins.
Yes, the question about the environment is a very, very top of the consideration in any R&D project. in order not to have any negative impact, you must minimize whatever chemicals you're using. And in my particular case, it's the copper that goes into the paint. The release of that is controlled by the paint formulator, and making sure that the release doesn't, you don't get too much in a very isolated spot is very tricky. Obviously, there is a strong development of moving to non-biocidal coatings, but up to now, they're very limited in use. I'm not sure I'm answering the question, but price also is a very good control of expensive chemicals. You don't put many in because they're too expensive, so you have to use very low amounts. So that's a good effect for the environment, price pressure. The anti-fouling market is a very competitive one, and that keeps prices down too. But from an R&D perspective, you're always thinking about the environment in every project you do.
Thank you so much, Dr. Colin. We have a next question to Mr. Ronnie. As you said that IMO is a target for 2050. Okay. Based on the current scenario, as we know that shipping sector actually very slow to changes. Okay, and one of the convention takes long time for ratification. Okay, so in this perspective, if the technology doesn't develop, and also there is no carrot and sticks method. Okay, so what do you think that 2050 is it a good target, or is it very ambitious?
Actually, I would say that 2050 is not ambitious. Like, technology is evolving very fast. We don't know if tomorrow we'll have something, right? So that can solve all of our problem. But actually, if we maritime industry, actually the regulation driven, and as IMO has a lot of nations, so they are not same. Like different country, they have different perspective, and they have the different capacity. So to take into account everything and to pass rules, it takes time. But we have, as a ship owner, we have the environmental obligations, and there are pressure from the other parties like financial organizations, some port, and many of the countries, they are taking their own initiatives to have the better vessels. You cannot keep on emitting such carbon dioxide to the atmosphere for so long. So that actually this is the time actually to need to take the technology in, because if you look back, technology of the ships does not improve much. Before 2012 or 2008, I say, when the ACMP considerations came in, and EDI came in. After that, only the people thinking the better vessels. Otherwise, we are thinking the fossil fuel and all these things. But I would say I'm optimistic that something would happen, and it will give us the better performance. But whatever we have now, the ship owner will go for it, and they will opt, and they will comply the IMO trajectory, and there is no way to escape, I say.
Thank you, Mr. Ronnie. We have another question from actually two of our members, a similar question. So I will rephrase it to one question to Dr. Colin. Okay. The question is actually, in case we are using a high quality SPC paints, as you said that we can delay the docking up to 5 years. But instead of, if we do, you said actually in your presentation that the hull cleaning is also an alternative or maybe supportive scheme for these anti-fouling measures. Okay, so Captain Rabiul and also Engineer Zahir, they asked actually with respect to this hull cleaning, whether it is beneficial, and also whether silicon-based paints, is it advisable to do like cleaning in between? Dr. Colin, please.
The US Navy keeps its ships out of dry dock for 12 years by cleaning. So cleaning can be very beneficial. They use quite a hard coating, and then they clean it regularly. Of course, they have their own garbage, which makes it easy and low cost. So cleaning can be a very beneficial target. And ships, if you go on the website of most paint companies now, 5 years is actually not what they say. Most of them have products that go up to 7.5 years, 90 months. So and that is nominally without cleaning. However, it's quite normal to get some degree of fouling in between in that 7.5 years or 5 years. And the grooming approach, where you do very soft cleaning frequently, by frequently I mean maybe once a month or once every 2 months, if you can do that and keep the hull almost clean, with even slime can have a negative effect on fouling, and that applies to the silicone paints, the foul release ones. Some of them can pick up slime quite rapidly, and that has a 5%, 10% even negative effect on fuel consumption. So if you can clean before you get any serious fouling, then you can keep your ship for 7.5, and as I say, the US Navy got up to 12 years. But by keeping cleaning frequently and often.
Thank you, Dr. Colin. We have one question to Mr. Ronnie from one of our member. He's actually asking about 0.5% fuel, which is currently in to comply with. Okay, so there are scrubber requirement as well as 0.5% fuel requirement. Okay, so the question is actually the how scrubber technology will be can be developed further, so that the price goes down and it become more beneficial for the ship owners.
Actually, I'm not expert on the scrubber, but it actually, from my study, I see scrubber gives savings, but it depends. If the fuel price is the margin of the fuel price, like compared to the NGO and HFO, is very less, so there is not much savings is given by the scrubber, because you were consuming HFO, you need to heating of the fuel. So there are a lot of companies, they are going for around like 46% of the company, they are going for NGO, and scrubber is, I think, below 10% of the company, they have gone for the scrubber. So it is not very popular. That scrubber is not very popular right now. Many of the companies, most of the companies, they are going for the VLSFO. Second option is the NGO, and then comes the scrubber. So there is very less, but scrubber technology actually did not get mature. There are a lot of struggle happening to corrosions and degradation of the main engine performance, because it is fitted in the main engine exhaust stream, and it takes up the flow of the exhaust is not much. So the main engine SFOC increases. So that thing taken into consideration, and the auxiliary engine consumption and all these things, it actually increases the fuel consumption of the fuel of the ship. Let's say VLCC around 2 metric ton fuel is each day. It contributes to the emission. There are more consumptions, right? So from energy efficiency perspective, I'm not a very big fan of the scrubber, but it's a part of a solution, actually, I said.
Thank you, Mr. Ronnie, and thank you, Dr. Colin. It was a very interactive question-answer sessions. I will now request Mr. Shakhawat to take over for the rest of the program. Thank you.
Thank you very much.
We are approaching to the end of this seminar. I would like to extend my sincere appreciation to all speakers for their excellent presentation, and a special thanks to IMarEST and BMCS for giving us this opportunity to arrange this technical talk. This presentation and discussion reveal that there are opportunities and challenges ahead to achieve the reduction target. To align with the 50% reduction goal, we need to reduce carbon intensity up to 70%, which is a very challenging target. To reduce emissions, we need to focus on effective implementation of energy efficiency measure on board and setting KPI of reduction, monitoring, verification, and implementation by audit. More incentive for energy efficiency activities and green technology. Supportive organization culture to promote energy efficiency. More training and education are required to address the skill gap. Is this 70% reduction possible with existing measure and current fuels? Presentation data suggests it is not possible with current fuels, and industry need to shift from conventional fuel to zero carbon fuel. There are few alternative fuel found to be prospective, such as biofuel, ammonia, and hydrogen, but they are expensive compared to fossil fuel. Price gap to be minimized. There are other issues to be addressed, like funding and investment for infrastructure development, supply chain, and bunkering, and also onboard storage. To accelerate the energy transition, all stakeholders, IMO, member states, governments, ship owners, builders, investors, scientists, fuel producers, legislators must work together and share the ambition in shipping decarbonization, which will ensure global trade in a sustainable manner. Dear viewers, thank you once again for your active engagement throughout the session. I hope we will have similar event in near future. Till then, wish you all the best and goodbye.